Hello class, today we follow up on yesterday's lecture on linear regression with a few slides that should help you complete your lab session and by extension should help you with your homework. So the first thing I want to do is to show you exactly how you would run a regression in Excel. Remember, the very first thing you should always do when starting a question like this is starting with a scatter plot. So click Insert. This is the icon for scatter plot. At least that's what it looks like on my Mac. It will look slightly different if you're on a PC. And you automatically get this graph. Be careful when you do that the X and the Y are in the right order. If not, you might get a graph that is the mirror image of what Pearson wants you to have. And again, this might look a little bit different in your version of Excel, but you should be able to figure it out. So the second thing is, how do you interpret a regression? So imagine you just ran a regression of quality rating on alcohol content. So quality rating is your Y, alcohol content is your X. And Pearson tells you that B0 is 3.6 and B1 is 0.4. They ask you for the meaning of the slope B1. The slope in math, you already know this, is the change in Y for a 1 unit change in X. And so here you just apply that concept to the two variables that you have. And so in this case, B1 is a change in quality rating for a 1 unit change in alcohol content. What is a 1 unit change right here? In this case, it's a 1 percentage point. And so the correct answer is this one. For each increase in alcohol percentage of 1 percentage point, the wine quality rating is expected to increase by the value B1, 0.4. Next question, they ask you to predict the mean wine quality for wines with a 12% alcohol content. You cannot read it off of this because 12 is somewhere here between 11.4 and 12.2. So what do? You just plug the value 12 into your regression. So your y hat, your prediction is B0 plus 12 times B1. B0 being 3.6, B1 being 0.4. How do you actually run a regression in Excel? Let's say you just opened your data, you plotted your data. So on Pearson, you will get questions like this that say, develop a regression model. When you see that, it means you have to run a regression in Excel. They tell you a regression model of what? They say it's of the cost per person based on a value that is the 3 ratings. So you know that this summated rating is your X, and they want you to predict the cost, which is your Y. They ask you to assume a linear relationship and use a least squares method to compute the regression coefficient B0 and B1. They give you room here to enter B0 and B1. What do? You go into Excel, you open the data, you click on the data ribbon, then the data analysis toolpath button. Then it opens this menu and you choose regression. So here you go ahead, you take the first column, you put it here, you take the second column, you put it there, and here what did you do? You just made a mistake. Why? Because you said that A was the Y and B was the X. You need to pay attention to which variable is the X and which variable is the Y. Y is what you want to predict. X is what you use to predict it. So since we are trying to predict the cost based on the rating, this is reversed. The way we input it here, we did the actual opposite of what they wanted. This is wrong. In fact, what you want is for column B to be your Y and column A to be your X. So this is better. It's going to predict the cost, the Y variable, based on the rating, the X variable. So this will give you the correct regression. The output will look like this. Where are your coefficients of interest? They're right here. These are the two most important cells in this output. And so all you need to do here is just plug them in. Minus 34.07 and 133.258, rounding up to however many decimals Pearson asks you to round up. You will almost always have a question about how to interpret the meaning of B0 and B1. Be careful, this sometimes is kind of a trick question for B0, because sometimes the X variable being equal to 0 doesn't really mean anything. So in that case, the B0 is not very meaningful. And that's the case here. The restaurants cannot have a rating of 0, and so B0 doesn't mean much. The slope has the same interpretation we just saw earlier. The next type of question you might get is a question about the r-squared or the SYX. Those are usually easy and simple to solve. SST, as you know, is the sum of SSR and SSE. SST is the sum of the other two, so all you need to do is 28 plus 12 equals 40. For r-squared, it's just a tad bit more complicated. You need to divide SSR by SST. So it's 28 over 40. Remember, SSR divided by SST is the regression sum of squares divided by the total sum of squares. It's the share of the variation that is explained by your regression. If you remember what it means, you will remember the formula. Of course, you don't actually need to remember it by heart because you will have your notes in the exam. But if you want to be quicker, just remember this. It will also ask you what the meaning of r-squared is. Be careful, this is a little bit unusual, but the way they write percent is by saying R2 times 100%. That is how they write 70%. So when R2 is equal to 0.7, I usually just say this 70%. They write it out like this. Don't get confused by this notation. R2 times 100% just means R2%. Sometimes it may be a little more difficult when they give you very big values for SSR and SST. My advice is to do these questions in Excel. It will go faster than trying to punch this into your calculator. Punch in the SSR, punch in the SST, and get the ratio of the two. Then they will ask you for the standard error of the estimate. Now, this is the correct answer. How did I obtain that answer given that all they gave me is SSR and SST and this number? Okay. Well, the first thing I did is I figured out the SSE. So how do you know that? Well, since SST is SSR plus SSE, then this is just the difference. SSE is SST minus SSR. And then all you need to do is plug it into the formula that you have in your notes, that SYX is equal to square root of this SSE divided by n minus 2. What is n minus 2 right here? It's 10. It's 10 restaurants is the n. So you divide SSE 8073.11 by 8, and then you take the square root and you get this. So you first figure out the SSE, and then you figure out the SYX. Last, I'd like to give you a few tips for making sure that you get the right answer in Pearson. The first thing is, let me insist, be careful when picking the graph. In this case, for instance, you plotted this graph in Excel. You immediately see that it looks very similar to this, but be careful. If you look at the y-axis here, you see that the values don't match. This goes up to 300, this goes up to 900. So even though this looks more like D, it actually is B. And you can see that the difference is just that they have a tighter x-axis and we have an x-axis that is more spread out. It's still, in fact, the same graph. Second thing, be careful with scientific notation. Sometimes your p-values are so small that Excel will write them like this, 7.53 E minus 08. What does E minus 08 means? It means that there are 7 zeros in front of that number. So it's not 7.53, it's 0.000000753. So in fact, this p-value is actually 0.000 with the 3 decimal places that they are asking for. Don't let scientific notation confuse you. And finally, last tip, this is for the last questions of the lab. I inserted some questions about multiple regression in there because I thought by that time we would have seen that material already. I haven't uploaded the video for that, so you might not recognize those questions just yet from the lecture. So the only thing I want to say here is that the interpretation of coefficients for a multiple regression, when you have an x1 and an x2, the interpretation of this 5 right here is the same as it would have been in a simple linear regression, except you have to add the assumption that all else is being held constant. So if x2 is constant, when x1 increases by 1 unit, y increases by 5 units. And of course, the reverse is true for the 3 here. It's the same as with a simple linear regression. You just have to hold the other x's constant. And that's it for today. This should help you solve all the problems in the lab, as well as the homework for this week.